Hello, and thank you for joining us for today's application webinar, Use PolyJet for Fast, On-Demand Jig and Fixture Production. My name is Kim Kaloran, and I'll be your host for today's event. Before we really get into the topic, I wanted to give you a brief overview of who Stratasys is. For more than 25 years, Stratasys has been at the forefront of 3D printing and additive manufacturing innovation. As a trusted leader in the growing 3D printing market, Stratasys brings an unmatched set of expertise for our customers' unique and specific needs. Stratasys is shaping the way things are made, providing technology and solutions to empower design freedom and manufacturing flexibility. We're shaping lives by helping doctors, dentists, and scientists significantly advance research, medical device development, and healthcare. We are inspiring the next generation of innovation through our work in aerospace, transportation, and education, and more. So for today's event, I'd like to welcome our main presenter, Hila Deshe. Hila is part of the Stratasys corporate applications team focusing on PolyJet technology. She joined Stratasys in October 2013 and has been involved in application development, supporting new product development, and supporting in the creation of sales, samples, and models. Hila holds a bachelor's degree in industrial design from Holon Institute of Technology in Israel and has worked both as a designer and in the jewelry industry. So welcome to Hila.
Thank you.
One other quick note before I continue on. At the end of today's webinar, you will get a link where you can access these slides as well as the recording and other information on the jigs and fixtures with PolyJet topic. So I'm going to continue on doing one more slide before I completely pass it over to Hila. Wanted to get everyone kind of on the same baseline for the different applications for additive manufacturing kind of as an overall. So traditionally, additive manufacturing or 3D printing has been used to do concept modeling as well as functional prototypes, so really testing the form, fit, and function of a new product or product in development to see if it's going to work before you actually go to the traditional tooling to make that product. More and more, we're seeing that additive manufacturing is being used in two different arenas, manufacturing tools and production parts. And today we're going to be talking more about the manufacturing tools section. This is where the topic of jigs and fixtures fits. Additionally, things like gauges, templates, guides, patterns, molds, and dies fit in the manufacturing tools section. And then, as I mentioned, also additive manufacturing is being used for production parts. These, collectively, we call this direct digital manufacturing. So now that we kind of see the landscape of additive manufacturing, I will turn it over to Hila to start on our topic today.
Thank you, Kim. So when talking about jigs and fixtures using PolyJet, there is a major focus these days on additive manufacturing application. Jigs and fixtures is one of the applications that is connected directly to the manufacturing space. There's always a need for jigs and fixtures in the manufacturing process, but there isn't always the time or money to invest in creating them. Sometimes the hassle involved or even just priorities will prevent creating more of them. Most customers that have a PolyJet system can also use it for creating jigs and fixtures. Even Stratasys uses their own systems to create many jigs and fixtures in the development process. In this slide, we can see a few examples of Stratasys using PolyJet for the production process. On the top image, we can see a vacuum calibration jig for the vacuum of the printers and a door handle for service engineers in the field. We will now see a short video about this application.
Jigs and fixtures are used throughout every step of a manufacturing operation, from the testing lab to assembly and on to quality assurance. They improve quality, reduce cycle time, and decrease labor. And jigs and fixtures do more than just hold and position parts. They're also used as templates, guides, gauges, trays and other manufacturing aids, and can number in the hundreds or thousands, depending on the size of the manufacturer. But ask any company that uses them, and they will tell you that they could use more of these manufacturing aids, but don't. Why? Because the effort, time, and cost to machine them is an obstacle. Many jigs and fixtures are viewed as nice to have, but not worth the investment or the hassle in light of traditional manufacturing methods. Most users also want better jigs and fixtures that are lighter and optimized for a specific operation. However, conventional manufacturing like CNC machining limits the ability to make them quickly and affordably. 3D printing with PolyJet technology is the tool to put more jigs and fixtures to work, and it is the tool to make them perform better than their machined metal counterparts. Customers report that the automated, unattended PolyJet 3D printing process delivers jigs and fixtures 60 to 90% faster, while dropping the cost by 50 to 70% compared with conventional machining. Although time and money are always critical, the real value is that they can make them whenever the need arises. PolyJet turns jig and fixture making into a simple task instead of a multi-step project. Just design, print, and deploy. That efficiency can also reduce the time and hassle of locating a jig or fixture when it's needed. Moving to a digital inventory, customers simply reprint them rather than storing them between uses. Made from lightweight plastic, PolyJet jigs and fixtures are inherently more ergonomic. But when designs leverage the capabilities of 3D printing, ergonomics and overall performance can be optimized. This means faster production, higher throughput, and lower rework rates. PolyJet offers one more advantage that is unique to the technology. It can make multi-material jigs and fixtures in a single operation. Just imagine a rigid fixture with integrated rubber-like interface surfaces for non-slip and non-marring production work. You can also use multi-material 3D printing for labeling, to embed a fixture number, usage instructions, or alignment guides in your jig, fixture, template, gauge, or guide.
The main benefit of using a PolyJet printer to manufacture jigs and fixtures is the time. It's so quick. We can design a jig during the day, print the jig at night, and the next day we come in. There's no need for any machining. We can then put that jig straight into production.
Adding more jigs and fixtures throughout your operation will improve the bottom line. PolyJet is the tool to help you do that, and the tool to make each one perform better. Visit Stratasys.com to find your local PolyJet reseller and discover how much you can benefit from 3D printed jigs and fixtures.
Okay, so after we learned a little bit about this application, in this presentation we will have a general overview about jigs and fixtures, see what the traditional process is, how PolyJet replaces that process, and what is the PolyJet role, what are the best fits for using PolyJet, and what are the benefits for using PolyJet for jigs and fixtures, and we will see a customer success story that is using many jigs and fixtures in their process. So, jigs and fixtures are a widely used tool in almost every industry in the manufacturing world. From very early stages of product development and R&D through assembly of parts and post-production operations such as trimming or drilling. Many jigs are used to hold parts during inspection and quality control, and they even can be used as organizers, end-of-arm tools, and help keeping track of inventory. So traditionally, jigs and fixtures are fabricated from machined metal, wood, or hard plastics. The process starts by defining the need for a jig or a fixture in the manufacturing process, then designing the jig or the fixture, creating the engineering drawings, programming the CNC machine and setting it up, the tools, machining the parts, one part or a few parts if we have an assembly, which might need multiple steps, and finally assembling the jig or the fixture and testing it. Of course, if something doesn't work or we need to change something, we need to do the whole process from the beginning. Again, in this process, there might be even additional steps if the process is outsourced, like receiving quotes, creating POs, waiting for the part to be produced, etc. Each step requires people to do, so there can also be a lag time between steps waiting for resources. Again, machining is often done in series, so if we need a few parts, we need to machine component A, and only when those are done we can machine component B, etc. With PolyJet, we eliminate all those steps, and we go straight from designing the jig to printing it and testing it. Of course, feedback and the loop exists in PolyJet too, but it's not that painful and it's much faster. So, like we said, with PolyJet, we create the jig directly from the CAD file and the STL. We can create complex and organic shapes very easily since there are no manufacturing constraints. If we're using PolyJet multi-material capabilities, we can integrate tool ID, part names and numbers, and even usage guides straight on the part itself. A typical jig can cost only a few $100s and can be produced in up to a day, and we leave all the design concepts in-house. So when would be a best fit to use PolyJet for a jig? When we need low quantities, from 1 to 100, and we need a size of a part between up to 30 centimeters or 11 inches in size. Of course, we can create larger jigs by building parts separately and then bonding them after that. Of course, the size of the part also is relative to the size of the system we have and the size of the printing tray. Most of the jigs that we need, most of the manufacturing environments are relatively moderate temperatures, moderate mechanical loads, and those are also a best fit when using PolyJet. As for the design elements of the part, moderate to thick walls are feasible and are a good fit for PolyJet. When we need frequent replacement, we just print another part really fast. And of course, complex and intricate designs can be printed without any more cost. So, some of the benefits of using PolyJet. Because the process is fast and efficient, you can create a jig or a fixture as you need them and make more of them. We don't have design limitations, and we can create a part that is optimized for its use, has better ergonomics, fits the operator that handles it. Using PolyJet materials can give us the advantage for creating soft touch areas and non-marring surfaces, as well as adding text. We eliminate the need for assemblies, since we can print all the pieces in one print, in one part. And because we have a digital inventory, we don't need that much physical storage space. We don't need to keep the jigs. If we might need them again one day, we can just print another one if the need arises. So our case study today is Rutland Plastics. Rutland Plastics are a custom injection molder, which means they create custom parts for their clients. Sometimes they have many secondary operations on the molded parts, which require fixtures. Of course, each fixture is customized for each job or each part that they create, and that changes a lot. Hence, they need many jigs and fixtures. For them, machining fixtures is very costly and time-consuming, and their in-house CNC machine is needed for creating production of molds. Using PolyJet fixtures basically frees up the CNC for production, and they can produce more molds for their jobs. They have used a lot the multi-material capabilities for creating non-mar surfaces to protect the parts they're holding, and for labeling. So for them, the benefit was really obvious. It was very fast and less expensive to create these jigs and fixtures with PolyJet. We will now see a video about Rutland Plastics.
I'm technical manager here at Rutland Plastics. We're predominantly a trade injection moulder. We can mould anything in any plastic on the market. We've got an Object Connect 350 machine which can print materials ranging from a soft touch rubber to a hard plastic. Predominantly we used to make jigs and fixtures machining them out of aluminium or steel. We now probably produce 90% of our jigs and fixtures on the 3D printer. It saves a lot of time and money.
We use a number of different jigs. We use them a lot in quality control to actually measure parts and components, also as go and no-go gauges. We also use them out on the shop floor to cradle parts while we add inserts, or actually using jigs to help us cradle parts while we assemble them, so it aids us in the assembly. The main problem with the traditional method of manufacturing jigs is it takes up a lot of time in the tool room. The tool room is there to predominantly manufacture mould tools, and when we're making jigs and fixtures, we're getting less work done on manufacturing the mould tools. The main benefit of using a PolyJet printer to manufacture jigs and fixtures is the time. It's so quick. We can design a jig during the day, print the jig at night, and the next day we come in, there's no need for any machining. We can then put that jig straight into production. And another great benefit is we can use a combination of rigid and soft touch materials in one print. It allows us to create soft touch faces. A lot of the time, if we're cradling a moulding, that moulding will have what we call an A face, which is a face that is going to be predominantly visible when it's on the marketplace, and we don't want this A face being scratched or scuffed. So we use a soft touch to actually create a protected surface, and it stops the part from getting scratched. We can add text to jigs. This text is quite clearly highlighted and it doesn't rub off. Using the object machine to manufacture jigs and fixtures, I think we save approximately about 60% on time and maybe about 40% on cost. The additional benefit of 3D printing jigs and fixtures is that if one gets broken or lost, we've always got CAD data which is quickly sent down to the printer, and we can then print another jig or fixture either during the day or overnight.
We did look at other machines on the market, but we felt that the Object machine would fit into our portfolio better and give us more versatility.
If you were thinking of getting a PolyJet 3D printer, I highly recommend it. Being a designer, we don't have machining constraints anymore. We can literally 3D print something that we wouldn't be able to manufacture any other way.
Okay, so let's go through a short recap about this application. So, who can use this? Basically, any manufacturer, anyone who has a need to produce parts and in the process has a need for jigs and fixtures. What do? We substitute the machine jigs with PolyJet printed jigs. When would we use it? Again, when we need more jigs and fixtures, but the hassle of creating them prevents us. And sometimes the designs are limited by the process, by the traditional process. So by using PolyJet, we don't have these limitations, and we can create better jigs and better fixtures. Where, like we said, in different areas of the manufacturing process, from early development stages through assembly or quality control, packaging, inventory, and why? Because it's simple, automated, easy, fast, and very efficient, and creates us parts that have better performance.
Great. Thank you, Hila.
Thank you.
In a minute, we'll take any questions that have come in from attendees during the presentation. And make sure, if you do have a question in the meantime, please submit it through the Q&A or the chat panels. After today's event, as I mentioned before, you will have access to download a copy of these slides as well as the webinar recording. And you can find those at www.stratasys.com/webinar-PJ jigs and fixtures. Also at this URL, there will be links to download additional documents on the application, technical guide, and customer story and application brief. Plus, contact your local reseller to request a benchmark be made for you to really get the idea of how this could work in your situation on your manufacturing or assembly floor. And you also would have a link on this URL to submit more technical questions to an engineer through an online form. So now we will continue on to the question and answer section. Looks like one or two questions are starting to straggle in here. Please keep them coming, as we'll try and get through most of them before our time runs out. So Hila, this first one is from Alice, and she is asking, how much does it cost? And I'm assuming she means, how much would it cost for them to produce a jig or fixture?
Yeah. So, Alice, this question, well, basically it depends on your part and what you're printing and the size and the material you're using to print the part. So it's kind of hard to tell how much will it cost. There are always ways to eliminate the cost by the way you design the part or how you print it. So it's kind of hard to answer that.
Sounds good. So it really just depends.
Yeah, basically.
Here is another one that just came in. Antonio is asking, he says he needs a strong, rigid material for his jigs, and what material would you recommend?
Okay, so from the PolyJet materials, we have digital ABS material, which is considered the strongest among the PolyJet materials. It's much stronger. It can be used in higher temperatures. So I would go with that, basically.
Okay. Sounds good. Here's another one. Max said that on slide 12 there was a picture of a drill guide. Looks like there's a bushing installed in the guide. Do features like bushings and threaded inserts have to be installed after the fixture is 3D printed?
Yes, very good question. Again, in some areas we might need assistance of external parts to help us in the jig or the fixture, so we can add them after the part is printed. Again, we can create create the holes or the sockets in the file itself to make it easier to insert them after.
Great.
Okay.
And I've got the picture of the image that he was talking about right now, so we can all refer to that. All right. Looks like we have time for another question here, probably our last one for this webinar. Ofer asks, are all PolyJet printers able to make jigs and fixtures with the different material characteristics like the soft touch and the identification labels?
Well, very good question. So not all of them, but many. We have a family of printers, the Conic systems. They come in different sizes, different variations, but all of them are able to print 2 or 3 materials and then create the multi-material parts.
Great. All right, well, it looks like our time is about up for today. If we didn't get to your question on the call, we will be sure to follow up with you later via email. Thanks again to Hila for her time and insight on this topic, and thanks to all of you for your attention during the presentation. Now I will turn it over to our operator, who will close out the event. Bye-bye.